Hello, learners, and welcome to the next part of our lecture about acid-base equilibrium. So new part, new pre-lecture. And this information is definitely going to include math from acid-base equilibrium problems and rights tables, so please make sure to review Chapter 13 info to help you understand this part effectively. In addition, you want to make sure that you're completing the pre-lecture and, of course, creating a one-page/brain map, and then also reviewing previous information and completing practice problems. Again, the lecture today is going to enhance or add to all the work that you did in the pre-lecture here. So let's go ahead and get to thinking, folks. So far, we have discussed Arrhenius acids and bases, Bronsted-Lowry acid and bases, conjugate acid-base pairs, autoionization of water, pH and its calculations, and then we learned that there are just a handful of strong acids and bases to memorize. Well, now, folks, we're on to the next part, and it's time to tackle everything else, which are the weak acids and bases. So these are going to be substances that only partially dissociate or ionize. They also represent weak electrolytes, and we know that they're going to be in equilibrium. So we see a forward and reverse reaction happening. Okay, folks? So we definitely get to see some of our old chemical Avengers like H2S Spider-Man and HS- Captain America, which represented conjugate acid-base pairs before. And we do get to learn about some new chemical Avengers like H2TE Hawkeye and CH3COOH Doctor Strange, for example. So there's lots for us to get into with this part. Let's go ahead and get organized. So in this part of the lecture, we're going to use some chemical Avengers to help us learn about weak acids and their equilibrium calculations by learning about a new equilibrium constant, which we call Ka, A for acid, okay? And this is also called the acid dissociation constant. Next, we apply trends in atomic and bond properties to determine trends in acid strength. Then we're going to get into weak bases and their equilibrium calculations. And also we get to see a new equilibrium constant, Kb, or the base dissociation constant. And then finally, we're going to learn about an expression that helps us relate weak acid and base equilibrium constant together. Okay, folks? So let's go ahead and get started with this portion.